Hello, hello. Good afternoon, everyone.
Good afternoon, ma'am.
Good afternoon, ma'am.
Okay, okay. Last class we I gave you one sum problem. Did you try after that? Anyone? The stresses at the top fiber, stresses at the bottom fiber. How much did you get? Have you calculated after writing the sum, problem sum? No, nobody has tried. Hmm. Bimal Rampi. Bimal Rampi. Have you tried or not? Hirok Jyoti. No, no, then try now. Now you try. This was your question. Where's my screen? It was easy, no? You have just had to find out the stress. This was your question. This was your question. How much was your area? You had to calculate these things, the stresses at the top and the stresses at the bottom. So all these things are given to you. Nothing extra is to be calculated. So just calculate and give me the answer. Anyone? Not anyone. I'll just randomly ask anyone from the lobby, whomever I'm just watching, whoever has joined the session. Um, Area you had calculated already. You know your pre-stress. Moment. How much is the moment for this particular question? Telsang Fungsu. What is the moment for this particular question here? Dimensions are given to you. Loading is given to you. Telsang. Hmm?
Uh, Trying, ma'am.
How much? Bending moment will be how much? The simple UDL is given to you. Anyone then? Um, Kinrong, I, Mansungo, Kinrong, Kinrong, KS. Hmm. See, this was your question, particular question. See, we need to find out here. I already gave you in the last class all the diagrams, like how for this particular question, how is the diagram? Then again, we need to find out in this question. It is asked that determine the extreme fiber stresses in concrete at the midspan section. At the midspan, and you know your span is how much? 6 meter. Your dimension of the beam is given to be this much. Your total load is 16 kilonewton. You have your pre-stress to be P is 960 kilonewton. So in the general principle which I explained you in the first class of today, there I already told you this is your extreme top fiber stresses P by A plus M by Z, and at the bottom is P by A minus M by Z. Because here no eccentricity is there, our tendon is at concentric. We have a concentric tendon, that means at the center, longitudinal axis, centroidal axis. So our total force or the total stresses, the stresses will be how much? This one, P by A plus minus M by Z. Because due to this pre-stressing force 960 kilonewton, this 960 kilonewton, this stress will be developed P by A stress, direct stress. Already in the first class I explained you. And due to that, the pre-stressing force and the external loads, another moment is there on the beam M. This bending moment, there will be a stress due to this moment also, which is M by Z. Z is the section modulus. What is the formula for section modulus? You know already. I by Y is 72 kilonewton. Jale, what? 72 kilonewton. The answer or what?
Yes, ma'am. Bending moment.
Hmm. How you have done?
By using the WL square by 8.
Yes, you're correct.
Thank you, ma'am.
W L square by 8, and how much you got? 72 kilonewton meter. She is correct. And the section modulus Z. Somebody calculate the section modulus. Others, the moment is already this one. Jale Kevin Kev Kevisno Chale. Yeah, she has already said you the moment is how much? 72. Bending moment is 72 kilonewton meter, which is W L square by 8. You know for UDL it is W L square by 8. And your W, you know the load 16 kilonewton per meter. Uh, L is how much? Your span is 6 meter. Already you know this thing. So she got it to be 72 kilonewton meter. Now we know P by A area. We already calculated P by A is the direct stress, which we can easily calculate. We know the pre-stressing force also. Now the moment we have calculated, Jale has already told you what is 72 kilonewton. The moment section modulus, you know what is section modulus already, you know. Z is equal to I by Y, is it or not? I, capital I by Y. I by Y. So what is your I for this rectangular beam section? For this rectangular beam section, what is your I? Moment of inertia. I is equal to BDQ by 12. Yes or no? I is equal to how much? B D Q by 12. And we have how much? We have y. Y is nothing but y is the half of the depth. Okay, which is your here in your section modulus. You already know. On the section, the dimensions of the sections were given to you. Okay, so that will be how much? This d by 2, that is y. Your y is d by 2. So now you tell me what is your section modulus z when you have your I is equal to bdq by 12 and your y is d by 2. Y is equal to d by 2. How much is your section modulus now? Section modulus. How much? Anyone? 2.4. How much? Hmm? Okafu? What is the Z section modulus?
200 miss.
Hmm?
200.
Hello?
300.
No. Section modulus Z. Z equal to how much? Z I told you it is what? Section modulus I by Y. I by Y. And what is your Y? Sorry, I. I is BDQ by 12 and your Y is D by 2. That means how much? BD square by 6 also you can write that. Calculate what is your BD square by 6 then. Abdul Latif, what is that?
24 into 10 to the power 6.
Okay, correct. Who was that? Mukafu.
Naldo.
Jumram. I'm
Okay.
JK.
Okay. So that means what? Your, yeah, correct. Pallab Talukdar is also correct. Z is equal to I by Y and I was our BDQ by 12. Y was D by 2. So in short, you can also write it to be BD square by 6. Yes or no? When your I is BDQ by 12, Y is your D by 2. So ultimately, in short, if you can want to calculate directly, you can calculate Z is equal to BD square by 6. So which gives your answer to be 2.4 into 10 to the power 6. Now once you get your Z is how much here? 2. Okay. If I not write like that, 0.4 into 10 to the power 7 mm cube into 10 to the power 10 to the power 6. Okay. Hmm. Now once you know, we know our Z, we know our area, we know our pre-stressing force, we know our moment. So now we know all the values, so we can easily calculate the total forces or not, sorry, total stresses or not. We are asked to find out the extreme fiber stresses in concrete at the midspan section. So our extreme stresses are how much? P by A. Total stresses P by A, the direct stress, plus minus the stress due to the bending moment M. Due to this bending moment, the stress developed is M by Z, plus minus M by Z. So stress at the extreme top will be how much? P by A plus M by Z. Now what is a P by A? Come on, tell me what is P by A. P you know, A you know. What is the value of P by A? P by A. P by A, how much? Calculate P by A, then also you calculate your M by Z. What is your M by Z? What is your P by A? How much is your P by A? P is given 960 kilonewton. Area you already calculated, 2.4 into 10 to the power 4. Solving 4 Newton per mm square. Okay. The P by A is this much. What is M by Z? I just want you all just to try so that it becomes easier for you. You will have practice also. You can easily solve then this kind of problems. P by A, Jhale got 4 Newton per mm square. Nanzia got 4 Newton per mm square. Everybody got 4 Newton per mm square. Everybody? Okay. M by Z. What is the value of M by Z? Moment we know. Z also we know. Section modulus. How much M by Z? Anyone? M by Z? Five. Who is that? Why all are getting 3 into 10 to the power minus 3 minus 6. Vicky Donald minus 6. Vanessa minus 6. Pallab Talukdar minus 3. Tovika 3 into 10 to the power minus 6. Chale is again correct once again. 3 Newton per mm square. Chale is correct. 3 Newton per mm square. Moment we already got, right? Take our M. Moment was how much? 72 kilonewton. So that means what? 72 into 10 to the power 6. Yes or no? When we write in Newton mm, because it was in kilonewton meter, now if we write Newton mm, 10 to the power 6. So now again Z, what we have our Z? Z was 2.4 into 10 to the power 7. 2.4 into 10 to the power 7. So when you divide this to m divided by z, how much you're going to get now? M divided by z. Now you calculate how much you get, because m we know it was in kilonewton meter, no? So in Newton, let's convert everything into mm, because area also we have taken in mm square, so that all the stresses comes in mm. So now what you get your m by z. Yeah, Vanessa 3 Newton per mm square. Kirong I Mansungo wrong, 3000 Newton per mm square. How did you get that? Subalamba, you're also wrong. See, this kind of silly mistakes, if you make, your stresses are going to be different. You will get different answers, different values. Your stress values will be different because of just silly calculation mistakes, maybe, or conversion of units, maybe. So we have got our m by z to be 3 Newton per mm square. And what we got our P by A, how much was our P by A? Capital P by A. How much was our P by A? 4 Newton per mm square. 4 Newton per mm square. Everybody got right now? The moment, the section modulus, P by A, M by Z. Everybody got the correct answer? Hello? Okay, yes. Okay, everybody got. So now once we have got our M by Z, P by A stresses, that is the direct stress P by A and the, suppose we have now what we have got, we have calculated our direct stress P by A, stress due to the moment M by Z. So now we can calculate the extreme top stress. That means at the top, how much is the stresses? In this, we can find out what is our, here, what is our top fiber stress, and here at the bottom also we can find out what is our stresses here at the bottom. So at the top is how much? At the top it is P by A plus M by Z, because this is going to be under compression zone. This is compression zone, this is tension zone. So P by A at the top, our extreme fiber stress will be how much? Now if you calculate and see here, Top fiber, how much will be your top fiber? Tell me. Top fiber. How much is your top fiber now? P by A plus M by Z. That means 4 plus 3. That means 7 Newton per mm square. And the bottom fiber, mid-span section, here at the mid section, what is your bottom fiber stress? Extreme bottom fiber stress, this here. What is your stress here? Yes, correct. 1 Newton per mm square. Okay, so in this way you can calculate your top fiber stresses, which is 7 in this particular question. You got it to be 7 Newton per mm square, and at the bottom fiber stress you got to be 1 Newton per mm square. So done. This was your total stresses. Understood, everybody? How you can calculate your top fiber stresses, extreme top fiber stresses, bottom stresses. Okay. So now once you have already calculated, now you have practiced. So now I'll show you the solution, which was this one. See here, area 400 directly calculated, section modulus BD square by 6, we got to be 2.4 into 10 to the power 7 mm cube. Maximum bending moment W L square by 8, this much 72 kilonewton meter. Direct stresses P by A, which comes to be this much 4 Newton per mm square. Extreme stresses due to bending moment will be this one, plus minus M by Z, which is 3 Newton per mm square. Now once you got your stresses, you have to draw these stress diagrams. So how we are going to draw? This one is your stress diagram. Here, see the stresses. This was your beam on a simply supported beam. This is a simply supported beam of span 6 meter given with a pre-stressing force of 960 kilonewton with a UDL of 16 kilonewton. This was your section 400 into 600. This is your direct stress, which is uniform throughout the section and the beam. So it is uniform in this way. 4 at the top also it is 4, at the bottom also it is 4 Newton per mm square stresses. So it is equal. Here the stress due to bending moment is how much? Plus minus M by Z, plus compression at the top and tension at the bottom minus. So what you'll do, your top fiber stress was how much calculated to be? 4, sorry, for M by Z, your M by Z was 3. So top will be plus, so 3. Bottom is negative, so this side 3. Now your total stress, final stress will be how much? This plus this top fiber is 4 and 3. So 7, so 7 Newton per mm square. And at the bottom you have how much? 4 minus 3. That means 1 Newton per mm square. So this is your final, this is your final stress, which is developed in this particular beam, simply supported beam, which is given to us in our question. Fine, everyone, the stress diagram. Okay. So now this was a concentric tendon. Okay, this was concentric tendon. Now the next question, tendons placed at eccentricity. Tendons placed at eccentricity. When you have an eccentric loading, here if you see, this is the tendon here. This tendon is placed at an eccentricity E. This is the eccentricity. This is the center of the beam at an eccentricity E. this pre-stressing tendons are placed here. That means it has an eccentricity. Now due to this eccentricity also you're going to have a movement due to this eccentricity. This is your E. This is your E eccentricity. Now what will happen is that due to the dead loads and life loads, what happened? You had a moment in this way. So it was plus, that means compression at the top, and minus at the bottom. Due to this moment, due to that moment, the stresses which are developed, there were plus minus m by z due to this moment. Now due to eccentricity you are going to have a moment in this way. Okay, p into e, that moment will be how much? P into e. So now your sign are going to change. That means your tendon is going to have a stress in this way. It is not going to bend in this way. This way. So your tension is at the top, and at the bottom it is compression. So when you have an eccentricity, what happens? You see here minus plus pe by z. Here you can see uh, whenever your tendons, you have an eccentric tendon, what happens? You're having three types of stresses. Direct stress, you know why? Because of the pre-stressing force. Next you will have this thing, you know, due to the loads, due to the bending moment which is developed due to the dead load, life loads. So due to all kind of loads, total loads, due to all the total loads, whatever is the moment, due to that moment one stress is developed, that is your plus minus m by z. This one plus minus m by z, and another stress is going to come which is here due to this eccentricity E, which is minus plus pe by z. This one, tension at the top and compression at the bottom. Since due to this eccentricity, it is moment is going to be in this way. Okay, so at the extreme, top fiber stresses will be how much now? P by A minus PE by Z and plus M by Z, and at the bottom will be P by A plus PE by Z minus M by Z. Okay, okay. Now if you see, if you take, okay, the stresses also, you can see the stress diagram here. This was your direct stress. This was your direct stress. This was your direct stress P by A, which is uniform throughout this action. Then we know stress due to the bending moment plus minus m by z. Just now we had also calculated these things. Another one is when you have an eccentricity, the stress due to that eccentricity is this one pe by z. That means nothing but this is also m by z. M is what? Pe here due to the eccentricity. The moment is p into e. So m by z basically. So at the top it is opposite side minus, since positive last time we took it to be in this way. The stress due to bending moment on the right hand side we took to be compression. So at the top left hand side we are going to take it as to be tension. So minus plus, your stress diagram is going to be in this way. So the total stresses, you know, at the top will be how much? P by A minus, we know here, PE by Z plus M by Z, and at the bottom P by A plus PE by Z minus M by Z. So in this way you can calculate your final stresses. Okay. Done. Our meeting is going to end for all participants in 5 minutes. Okay. I'll take the attendance. 1,
Present, ma'am.
2, 4,
Yes, ma'am.
5.
Present, ma'am. Number 5.
Yeah, you tell the enrollment. Then 5, 96.
6, ma'am.
Okay. 7, 8,
8. Yes, ma'am.
8, 9,
Yes, ma'am.
9, 10, 11, 12,
Yes, ma'am. 12.
14, 15, 17, 15.
Ma'am, 17.
15 is present.
Present.
Tell me your enrollments,
14,
okay?
ma'am.
14. Okay. 15,
Hmm.
17,
Yes, ma'am, 17.
18,
Yes, ma'am. 18.
19.
Yes, ma'am. 18.
Okay. 19, 20,
Yes, ma'am.
okay,
20.
20, 21.
Yes, ma'am.
Okay. 22, 23.
23, ma'am. Present.
Okay. 24. Subhagalita. 25. Ikram Hussain. 26. Wangsu.
26 present, ma'am.
Okay. 27. Sorry.
26.
Okay. 30. 31. 32. 34. 30. 30.
32.
Okay.
32.
Okay. 34. 34.
Present, miss. Present,
Okay,
miss.
34, no? 36.
Yes, miss.
Present, ma'am. 36.
37.
37.
38.
Present, ma'am.
38.
38 present, ma'am.
Okay. 39.
39, ma'am.
42. 43. 45. 46.
Present, ma'am.
50. Hello. Tell me your enrollment, please. 45 or 46?
45.
45. Okay. 46.
45.
Okay. Okay. 46. 47. 48.
48 present, ma'am.
Okay. 49.
49, ma'am. Present.
Okay. Then 50.
59.
50. 51. 52.
51 present.
Okay. 52. 54. 55, 56, 55, 55. Oh my God,
I'm 54.
just mute. 55, 54 present. 54,
Yes, ma'am. 54.
55. Okay, 55, 56, 57, 58, 59, 60.
60, ma'am.
Okay,
Present.
61, 63.
Yes, ma'am. 63.
Okay, 99.
Yes, ma'am. 99.
Okay, 101,
Yes, ma'am.
104,
Yes, ma'am.
106.
Ma'am, 61, ma'am. Ma'am, 61.
Okay,
104.
106,
Present, ma'am. No, ma'am. Present,
108,
ma'am. 108, ma'am.
109.
109, ma'am. Kelsam. Present.
Okay, okay, 111,
Present, ma'am.
113,
Present, ma'am. 113.
140, okay, 114,
Present, ma'am.
100,
114.
okay, 115, 118, 120,
Present, ma'am.
124,
124.
okay, 133,